Hi guys, so welcome back to my YouTube channel. Today I thought it'd be very interesting to teach you about deriving labour demand. So labour demand, what does that mean? Well, we need to think to ourselves, who demands labour? And well, that means who needs employees? Well, it's firms, right? They're the ones that need employees. But have you ever sat down and thought to yourself, how actually do firms come to the conclusion that they need to hire, let's say, 5 people this year? And that's the brilliant thing about economics. It can add maths to all of the behaviours that everyone takes in an economy, and that's exactly what we want to do because we want to try and understand people's behaviours. How do they decide how many people to employ? You might be starting to think about, well, it's got to do with money, right? Because firms care about making money. Okay, so they want to be able to make money from it. But let's not forget the fact that they've also got costs. They have to pay the person they've employed. So what is that sounding like? That's sounding a little bit like profit. You've heard about profit. It's basically the amount of money you make, take away what we spent. So take away our costs. Okay, so they don't just care about profits in absolute terms. What do they want with their profit? Well, ideally, firms want to maximise their profit. So they want to hire labour so that they maximise their profits. And actually, profit maximisation is what's known as the producer's problem. So let's start adding some maths behind this. So as you can see, profit is equal to total revenue minus total cost. We can actually start to write these in a bit better terms. So total revenue, well, what is that? Well, it's technically the price times by however much we sell, so our output, and we typically denote output as Y, so P times Y. Can we write Y a little bit better? If we assume that what goes in to make a product is the people that work on it, so L, and the capital, which is typically buildings, machineries, equipment, then we know that Y is a function of K and L as seen. Let's move on to total cost. Well, what are our costs that we're incurring if we were a firm? Well, firstly, it's basically the amount that we've got to pay our labour force. So we're going to say it's our wages, W, the wage rate, multiplied by how many people we go on to employ, so L, labour. Typically, there are more costs than that. We mentioned capital earlier, and typically what tends to happen is you rent capital, there's rental rates. So what I've put that down as is RK, so the rental rate of capital. Okay, so we've got profit down, which is fantastic. What are we doing with that? We don't just want profit on its own. What did we say? Well, we said they want to maximise their profit. So what we want to do is we want to maximise this function, and obviously our choice variables are K and L. The choice variable that we're caring about today is obviously L, because we're caring about how much of L we choose. Well, you've heard from secondary school, whenever you got a question, if this was a maths class and you got a question on maximising or minimising, you'd tell me to differentiate it and set it to 0. Well, that doesn't change here. So let's differentiate this function and set it equal to 0. So if you differentiate a function, we can write that as just f subscript L, that's the thing we're differentiating with respect to. We're going to set it equal to 0, and we're going to neaten this up, and we're going to rewrite W over P as little w. It's obviously the real wage rate, because as soon as you take price into account with a variable, it becomes real. So we've got the real wage rate. Now, this F subscript L, K of L, what does it really mean? What are we doing? Well, what does that mean? It means we're differentiating our output with respect to labour. And we've got a term for that in economics, which you've probably already heard, and it's called the marginal product of labour. Basically, how does our output change when we increase our labour force by 1, for example? So what we're seeing here is we're seeing that marginal product of labour is equal to the real wage rate. That is how we determine the amount of people we're going to employ if we were a firm. Now that's great, but let's try and think about that a little bit more intuitively. Does it make sense? Well, it does. If we take the marginal product of labour as being how does our output change when we increase our labour by 1, what this is saying, that's essentially our benefit, right? How much benefit are we getting by employing that extra person? So I like to think of the marginal product of labour as benefit. And then the right-hand side of that equation, we've got real wage rate. Well, I like to think of that as cost. That's how much it's costing us to have that extra person. So what we're saying is we're going to employ up until the point where benefit is equal to cost. So, in summary, if you want to derive labour demand, all you need to do is you need to find your marginal product of labour, which is just your output differentiated with respect to L, and then go and set it to the real wage rate, and then you can rearrange that and solve for L, and you know how many people to employ. Let's actually put this into practice and do a question. So you might get asked to derive the labour demand when y equals ak to the fifth L to the 4/5. So you straight away notice it's a Cobb-Douglas function. Okay, so what do we know? Well, we know that we maximise profit when the marginal product of labour equals the real wage rate. And we've denoted it as W, but obviously W is big W over P, so the real wage rate. So what do we need to do? We need to first find the marginal product of labour. Well, that's just a fancy way of saying delta Y by delta L. So differentiate the production function you've been given with respect to L. When you do that, we're going to bring that 4/5 power down, and then we're going to minus 1 from the power. So we're going to get 4/5 a k to the fifth L to the minus a fifth. So let's now go and set that equal to little w, because we know that's the condition that needs to hold when we are maximising profit. Once you have gone and set that equal to w, it's just an algebra game. So what are we trying to do? Well, we're trying to find L. So let's neaten this up so then we can start to rearrange it. So using our rules of indices, because L is to the negative fifth, we can put it on the bottom and make it positive, as we have done so. Now what we want to do is we want to get L on its own. So we're just going to try and rearrange it to get L. So all I'm doing is multiplying both sides by L to the fifth. Then we're going to divide through by that little w, so L to the fifth is left on its own, as you can see written there. Now remember, anything to the power of a fraction is actually a root, so what that is saying, it's saying fifth root L. So what we need to go and do is we need to go and undo that. Well, the undoing of a root is to do the other side to the power, so we need to make the other side to the power of 5, and therefore we're left with just L equals. We can actually neaten this all up by actually doing everything in those brackets to the power of 5. So go and whack that into a calculator and you can figure out the numbers there. So what you end up getting is you're getting 1024 a to the 5 and k obviously to the power of 1 divided by 3125 w to the 5, and that is what labour demand is. So you have successfully gone and derived labour demand.